All right, there we go. Pamela, can you hear me?
I can hear you just fine.
Okay, so I just want to warn people in advance that there's a really big delay between the audio and the video. So when you hear Pamela talk, it then takes about another 5 seconds or so until you see Pamela talk. And this is happening because you're in Europe right now.
I'm in Warsaw.
You're in Warsaw. You're hiding in some corner of a conference, right?
Yeah, I'm actually currently sitting behind the podium while we're on break, just sort of leaning against the wall in a mostly empty conference room. So this is where I am.
So what is the event that you're at right now?
I'm at the Communicating Astronomy to the Public meeting. I'm also sitting on the floor, which is a comfortable place to sit at the end of the day. I'm at the Communicating Astronomy to the Public meeting, which is hosted by the International Astronomical Union's Division 55.
Oh,
And
so I gotta let a cat out. Hold on one second. She was just gonna keep meowing at me if I didn't do that.
no problem. So I'm at, this meeting is organized by the International Astronomical Union, Division 55, and we have 200 people from 40 different countries here. And we're all working to define ways to get astronomy out to broader audiences. And it's been kind of amazing. We've seen everything from planetarium shows to new planetarium technologies. There's actually a planetarium in rural Spain that the dome rolls off. So I've heard of roll-off planetarium, not roll-off observatory roofs, but never a roll-off planetarium dome. But they have a telescope and a planetarium projector inside of their planetarium, and so they'll just roll off the planetarium dome to look at the actual sky, and I think that's really kind of
Oh,
awesome.
like use a laser or something to point out objects in the sky.
Yeah, and they have tablet computers at the seats inside the planetarium so that people can control both the planetarium show and see what's coming off at the telescope, and it's
That's
just
really
a
cool.
really awesome. And there's been everything in between, from teacher training programs to citizen science programs to, well, everything.
So we don't have a lot of time today because you are really, taking stolen time in between the conference event. So
Yeah.
let's just get rolling with the show, and we're not going to have time to stick around for questions today. And so again, if you're watching this and the delay is still happening, I highly
We know.
recommend that, yeah, we know that you just, like, put another tab in front of your YouTube video, and then you can go from there. Okay. All right. So let's get ready to record. Are you ready to record?
Yeah,
Do you need to ask those
I'm
people
looking.
to stop laughing?
I'm in the middle of a science center. I can't go out into the floor and ask the children doing science to stop making noise.
I I think they would if they knew. All right.
I think it would
Go
be a
crack some
losing
heads. Go
battle.
crack some heads. Get out there. Yeah. No, no. Let me know when you're ready.
I'm ready.
Okay. I'm gonna press record.
Okay, I pressed record.
Testing, testing.
Where is
Oh,
my audio coming from?
testing, testing.
Hold on,
Okay.
being confused.
Uh-oh. I'm gonna
I
stop
have
my
no
recording.
clue. Yeah, I'm trying to figure out where my audio is coming from. I have no idea where it's taking audio. That's problematic.
Is it coming from the camera?
Well, it's supposed to come from the camera, but it wasn't. That's why it looked like crap.
It's funny. We've done this so much that you can look at a waveform and know if it's any good or not. You don't-
Yes. Okay, I'm ready to press record again.
Okay.
I'm pressing record.
I have also
Testing,
pressed record.
testing. Oh, this looks so much better. Okay.
Okay,
Life
good.
is
Good. Are
life is
the
good.
waveforms are good?
Yes, they are,
All right. Oh, I lost
or
my.
at least comparably good. It's not my home setup.
Okay, here we go.
Sorry, Preston.
Astronomy Cast, episode 317, Observatories. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. So we're recording this, and you're in a strange location. Where are you?
I am. I am in the Copernicus Science Center in Warsaw, Poland, and I am here along with roughly 200 other people from 40 different nations as we discuss ways to more effectively communicate astronomy out to the public. And everything that we're doing, we are live streaming it out using Google+. So you can go to my YouTube page, /StarStrider on YouTube, and under the videos get access to everything we've done outside of the planetarium. I couldn't figure out how to live stream planetarium content and make it look good. So that's the only thing that we're not live streaming.
That's really cool. Yeah, I wonder how you would do that. Some kind of like
I don't
really
know.
wide screen 14mm lens with yeah, no, that'd be tough. That'd be tough. Cool. Well, that's great. And so hopefully you're going to share all of the experiences that you've had in communicating astronomy to the public and learn some of theirs.
Well, we've all been working together since the International Year of Astronomy, and now we're looking forward to the International Year of Light, trying to figure out what we're going to do for that, and just sharing all of the different things that we're doing.
And so I apologize in advance. You've got you're sort of hidden in the corner of a of the science center. There are people walking around looking at the exhibits and talking. So that audio may make it into the recording. All right, well, let's get going. So have you ever wondered what it's like to visit one of the big research observatories like Keck, Gemini, or the European Southern Observatory? What's it like to use gear that powerful? What's the facility like? What precautions do you need to take when observing at such high altitude? So, Pamela, what sort of research facilities have you been to?
I have worked at Keck, at McDonald Observatory. I've gotten to go out to the Space Telescope Science Institute in Baltimore, which controls the Hubble Space Telescope and will be controlling the James Webb Space Telescope and Fuse and other telescopes. I've worked at the 6-meter in the Soviet Union. I've been to Yerkes. I worked at Haystack Observatory in Massachusetts. I'm going to stop now.
That's a lot. Yeah, no, that's tons.
I could keep going. I've visited others, and yeah.
Right. Okay.
It's a big world of optics.
And so, for most of us, like I've actually never been to an observatory, and I really should at some point go and do a tour.
You have no
something.
excuse.
I know. Well, I live on an island. That's the excuse that I have. But what so for people who have never been, what's the experience like? How do you get up there for starters? And then let's start with that.
Well, how you get up varies wildly from facility to facility. There's a telescope in Spain where you actually start out at the base of a ski resort, take the ski lift up, and then hike a little ways and get to the telescope. And so you see all the skiers and then the occasional astronomer with their briefcase. They don't quite look right on the ski lift, but they tend to fall less getting off than the skiers do. Then there's some observatories in Europe where you have to take gondolas up, the type that dangle from wires, not the type that go down rivers. In Wyoming, there's an infrared observatory where during the winter they have to use a snowcat, which is one of those vehicles that has treads on it like a tank has, because that's the only way to get through the snow to the observatory. But most of the time you just drive there. The 6-meter in the Soviet Union, when I was working there, when it was the Soviet Union, the telescope's still there, but the country's changed names. Back when I was there and it was the Soviet Union, they had a bus that ran up and down the mountain multiple times a day, taking staff and observers up and down the mountain. At McDonald Observatory and most U.S. facilities, you just drive up from the nearest city to the top of the mountain and you stay there in dormitories until you're done with your observing run.
And then what sorts of things do they usually have at these facilities?
Well, beds. Beds are a necessary one.
Well, yeah, but they have.
I'm a bit sleepy, so that.
Yeah. But
That's the most important one at the moment.
right.
So it's you have. Go ahead.
Oh, I was just gonna say. So I mean, like, I mean, obviously they're gonna have the telescope and the actual observing equipment, but I imagine there's lots of support buildings and other types of facilities up there.
I think it's probably a lot emptier than most people imagine. You have the observatory buildings, most of which are big enough that they have a few staff offices in them, uh, restrooms, a lounge of some sort in some cases. Um, but at the top of the mountain at major facilities where you have multiple telescopes that share facilities, you'll have some sort of a small dormitory, a kitchen facility where they usually have a paid cook that makes meals and then sets something aside for you to eat at midnight for night lunch. Some observatories even have a cook that stays on all night. At McDonald's, we were just sort of left with pots of soup and whatever we stuck in the refrigerator before the cook left for the day. Um, and then there's usually some engineering facilities and facilities to resilver or reilluminize the mirrors. But that's about it. You'll have a couple of houses for the staff that live on the mountain full time, but most engineering doesn't happen on the mountain. Most of it happens at universities, and you ship in your instruments and attach them to the telescope, and that's it. So
And now
domes, one or two buildings, and dorms.
when you're actually up on the mountain, are you doing like is there facilities like where do you do your observing? Is there some kind of observing room or where
It
the
depends on
computers
the
are?
telescope. It depends on what instrument you're using and what telescope. In most big facilities that are older, there's a control room off of the dome floor, and there's wires running from inside the telescope into the control room, and you do everything from a slightly warmer room. But if you have the misfortune of using an instrument that doesn't have cables that are long enough, you're sitting beside the telescope the entire night, freezing to death. And in many instances, like the 107-inch at McDonald Observatory, you can't trust the telescope to not collide with things. So whenever you're slewing the telescope from one point to another, you have to run out to the dome floor and control the telescope from underneath the telescope so that you don't do it any harm. Um,
Right,
but it
and
really
breaking your body.
varies. Yeah, well, if only. Um, but there's facilities, for instance, down in Hawaii, where they stick a lot of the controls at 5,000 feet, and the telescopes are substantially higher up than that. And the idea is, let's not kill the astronomers, because it does wear and tear on the heart to go up and down from altitude, and not everyone can function above 10,000 feet. There's just not enough oxygen.
Yeah, and I guess that was the next thing. It was just sort of the physical effects. When you go up to some of these mountaintops, what kind of physical effects do you feel?
Well, the first thing you notice is you get out of breath a lot easier. You get tired a lot easier. And so, like, our tradition at McDonald was after dinner, we'd go for a walk on the ring road around the top of the mountain and just check the horizon for weather and see what we'd see. There was javelinas and deer and other cool animals, but mostly it was the go out and curse the clouds part of the evening. And even though it's a flat road that just rings the top of the mountain, we'd get out of breath periodically if we got to walking and talking too fast, and that's belittling at times. And you get so cold at 5 a.m. That's one of the things that you notice first is your body at a certain hour of the night starts using expletives and then starts punishing you by making you shiver. And when you're observing, even if you are in a control room, you can't use a lot of heat because heat finds ways to escape. And so you'll be all bundled up, only minimally heated. And I remember trying to warm my hands on lampshades more than once. On the sides of old school monitors, CRTs were brilliant for warming hands. Uh, and just trying to keep warm. And there are nights where you're like, oh, sun just come up, because you're so cold and you can't waste a minute. And so you're just cheering the sun on, so that you can go to bed and warm up.
Yeah, I mean that's got to be such a strange experience that you're up at this altitude. It's very cold. It's at night. You're up and trying to do work and trying to think at times when you really feel like you want to be asleep.
And often you're utterly alone. I mean, that's the thing, is you're in your telescope by yourself controlling it at some facilities. Most newer facilities have night observers that are doing all the controlling of the telescope. But places like McDonald, you're by yourself in the dome.
You
So
go
you're
up and there's
alone,
the telescope.
cold.
Plug in where you need to and use it, and we'll see you in the morning.
Yeah, exactly. And there's friendly staff members who walk around and check on you. I remember there was one night I was in the control room, radio all the way up, singing to the music. I turn around and there's the engineer. And he more than once caught me where the weather had changed during the middle of an exposure. And he's like, "What are you doing?" I'm like, "I'm taking data." And then he'd just do this little finger thing and walk me outside, and a giant cloud had decided to materialize directly over where I was pointed on the sky.
Right.
So they do take care of you and make you feel stupid.
And so what is the process that for you to actually like reserve time on the observatory?
See, reserve time makes it sound like I have options. No, so almost every major telescope, the process is a very, very competitive one. So it's not that I'm reserving time on the telescope, it's that I'm applying desperately in hopes that they'll like my science. So your typical telescope application includes an abstract that summarizes what you're planning to do, a detailed technical plan that specifies how you're going to use the telescope, that demonstrates that you've calculated out exposure times correctly, that lists out what filters you're planning to use, what instrument on the telescope you're planning to use. And then you need a scientific argument that explains why using this telescope at this time with this set of filters will allow you to gain insights that you couldn't gain somewhere else. And it can get really frustrating because sometimes you end up in cases where you're trying to get time to observe something in the infrared, and they tell you, well, you should go get X-ray data first, and then you apply for the X-ray data, and they tell you you should get the infrared data first. And sometimes it's a matter of you apply, and they like you well enough, but what you really needed to complete your entire study was 3 weeks of time spread out over a third of the year. And they give you 2 weeks time. So now you have to change your study and refigure out what you're going to do. But it's a highly competitive process, and you have to be able to justify what you're doing and why you're doing it with the telescope you're using or hoping to use.
Right, okay. And so sometimes you have to change the actual science that you can get done based on the amount of time that you can actually get on the equipment.
Yeah, and if you have clouds, there's no redemption. You don't get that time back. So you have to always build in for if it's me observing, I'm going to lose 20% of the time to clouds. I have a personal issue with the universe, apparently. Mm-hmm. And then you have to be prepared to change things on the fly. So you always have the optimized list for, at any given hour, what are your priorities, and you have them scattered across the sky. So if there's issues over here, hopefully you can observe over here. And if you only have one target that you're interested in, you can get in a lot of trouble.
Right, right. Okay, so let's say then that you've gone through this process, you've submitted your application, the observatory has booked you some time.
Yes.
And so then what is the process in sort of, I don't know, understanding what, I'm trying to sort of explain this. Every different telescope is going to have different, it's going to have different facilities and different tools and software and hardware. And, how do you integrate your science with their facility?
Well, so it depends. Again, every facility is unique, which is a blessing and a curse. And so if you get lucky or unlucky, depending on what you like, it's a queue-based system. So they put your desired observations into a list, and software pulls it out, steers the telescope, takes your data, and then you get the images back at your home facility, you download them across the internet, and you're off and doing science. If you're going to
So
a
like you just put it in an
facility,
order to like
yeah,
Amazon,
exactly.
right? And they just
Yes.
show up.
The form is much more complicated. It's more like trying to order a computer off of
Right.
Newegg. Um, but yeah, and then if it's a system where there's night observers and you need to be there, so if you're doing, many of the telescopes in Hawaii work this way. You fly down, you have your binder of finding charts or CD of finder charts. You have all of your priorities and your contingencies for bad weather, and you sit next to the person who's actually controlling the telescope. They take all of the data, and then again, you're handed your data and you go off. And almost all the images that come from ground-based telescopes are in one file format. Pretty much everyone uses FITS format. There's also a format, IMH, that gets used by IRAF that some of the older telescopes spit out, or some of the telescopes that still run IRAF as a control system spit out. But the file format generally isn't an issue. But then if you're at one of the telescopes where you have to be able to control the telescope, if it's your first time going, you find some graduate student who knows how to use the telescope, and you offer them some minor amount of money, or sometimes just to feed them for a period of time, and they go out and they teach you how to use the telescope. And that was one of those things that I did in graduate school periodically, is I got to train professional researchers from all over the world on how to use the various telescopes out of the mountain.
And I'm guessing then that the control system for the telescope is different for every telescope. It's going to be a custom job a lot of the time?
Well, there's families of telescopes. So for instance, there's the Bolin of telescopes. These are telescopes that are generally between 20 inches and maybe 48 inches in diameter. They're a Rishi-Chrétien optics design. And the originals of these, they have dials on them where when you're pointing the telescope, you're reading the RA off of one dial, which only has positive numbers, and it's like reading a clock. But if you're on the declination side of the dial, when you go south of the equator, you have to switch from reading the numbers inside the circle to reading the numbers outside the circle. And at 4 a.m., figuring out where you just pointed the telescope can get very tricky, because you get dumb at 4 a.m. And so I know I reached the point of I would like draw out while I was awake what the dial of the telescope should look like if it was correct, and pattern match. And then other telescopes, you type in the coordinates and you press go and it goes. And there's everything in between.
And right, okay, and so I can imagine then in those cases you're out there and I mean, it's dropping these FITS files into some shared directory. Like they say you have some directory. Now, what if you've got, as you mentioned, you've got, an instrument of your own, some kind of custom instrument that you're actually hooking up to the telescope?
Then you probably brought your custom computer with you. And so the mountain staff, custom instruments are usually built by people that work at the facility that they're using, or they're going to a national facility where they've worked with the engineers at the national facility. So not every Joe can show up with their IR camera and hook it into the light train of a telescope. But if you are given the opportunity to test new equipment, to have a custom high-speed imager or some other unique piece of equipment, you show up, and the day that you're going to start observing, your day might start at sunrise. And as soon as the previous night's observer gets off the telescope, you start bolting on your equipment, working with the mountain staff to not break anything. And then you're observing all night. Astronomers are people who have selected careers where throughout the entirety of our professional career, we're going to have to pull 36-hour shifts now and then. And that's just a fact.
Yeah. Yeah. Now you had mentioned that you've been to the Space Telescope Science Institute. So
yes.
How does, I mean, obviously you can't go up and and sit beside the Hubble Space Telescope and bolt
No, you
your
can't.
laptop into its output. So what is that experience like?
It's a cube-based telescope. In a lot of different ways. There's no difference between using the Hobby-Eberly telescope at McDonald Observatory and the Hubble Space Telescope, except Hubble does have more money for support. In both cases, you're required to fill out a very detailed form on how it's a table. You set all of the parameters, and it gets read by software that then verifies you're not going to break the telescope. And that acts as a set of commands to configure the telescope and point the telescope to take the data you need. It sets the exposure times so that you get enough photons, and then you wait for the data to come to you. Now, with major facilities like Hubble, they often have what are called data pipelines. And this means that not only do you get the images that you need of your science image, but you also need a variety of different calibration images. And any telescope you go to is going to have these calibration images. Typically, it's a set of images taken with the telescope completely covered, or at least the camera completely covered. And these calibration images are measuring, are there hot pixels? Is there electronic noise in the system? And how does all of this noise and these hot pixels grow over time? So dark images, depending on the telescope, might always be the exact same time as the exposure you took, or they might step through and do a whole series of them at a variety of times to build a mathematical model. You do bias images. These are 0-second exposures in quotation marks there, where you're just reading out the CCD to look for noise in how the electronics exist and how the electronics read out the information. Then you also need to take into account any flaws in the optics. So you take what are called flat field images. These are images that have even illumination across the entire chip. Or you do sky flats, where depending on technique, most sky flats, when you hear that phrase, it's someone taking flats of a twilight sky, which is evenly illuminated. But another technique is you take a bazillion different images that are lined up differently, and you add them all together using min-max rejection. So you reject, of your bazillion images, bazillion minus 5 of the brightest, bazillion minus 5 of the faintest pixels, and you only keep the 5 images that are in the middle, and for each pixel. So pixel by pixel, you reject all but the 5 brightest and faintest, and you median combine those to get at what is that pixel's intrinsic brightness. And you use that to correct for dust, for scratches, for flaws in your detector. Normally, for a lot of telescopes, the scientists will get very persnickety and demand all of their own images and do all of their own data reduction. But some systems, and Hubble's one of them, they do such a good job with data reduction with a data pipeline that unless you're doing very specialized research, you trust Hubble's pipeline, the set of software it's put together to process these biases, flats, and everything else. Hubble's one that you don't do flat illuminations with. But you trust their pipeline so much that the final images you get are pretty much ready to go for science. And the other great thing about Hubble is if they really like what you're doing and think that it's newsworthy, they'll also put together press-ready color images, because all of the images we do for science, they're black and white images through filters. So to get those gorgeous, stunning Hubble images, gorgeous, stunning VLT images, gorgeous, stunning, name the telescope color images, you're combining images from a variety of different filters, and you do there. It's a fine art.
Right.
And it's a fine art that you don't master as a PhD scientist unless it's your hobby. But they have people that are employed, especially with the Hubble Heritage Project, just to learn how to make artwork out of your science. And it's fabulous to get to work with these people.
That's really cool. And I guess obviously you don't have to worry about clouds, and you don't have to worry about atmospheric disturbances, so I think a
Yeah.
lot of the precautions that you have to take with other observatories don't have to happen with Hubble.
Yeah, my favorite moment as an observer was oftentimes when you have passing clouds, you leave the dome open and you just keep an eye on what's going on and you wait for them to pass so that you can go back to observing. Um, but there was one time we had passing clouds and we noticed that it was starting to snow and closed up, and we looked across to the 82-inch. This is at McDonald Observatory. I was on the 107-inch, and we looked across to the 82-inch, which is nearby on top of the mountain. And their dome was rotated towards us, and we could see they were wide open, and their telescope was getting snowed on. So you have to be aware of many different things. You have a weather station that you rely on, and when you're observing, you don't just worry about snow and rain, you worry about humidity, because humidity can destroy a detector. You have to worry about dust. Dust coming in and settling on your filters is catastrophic, and not all filters can be easily cleaned. And I know I'm responsible for the death of about a $1,500 filter because there were forest fires, and we didn't think through that the fine grained soot from the forest fires wasn't something we should be cleaning off of our optics with isopropyl alcohol, which is what we always use to clean our optics. Turned out that isopropyl alcohol plus whatever the heck was in that soot, we ended up acid etching the surface of our filter and destroyed it completely.
Ouch.
That was one of those moments I was in trouble as a graduate student. But mistakes get made at altitude, and I luckily never made some of the most common mistakes, which are forgetting to turn off the telescope's tracking, and so you go to bed and your telescope's still slewing through the sky from wherever you left it last. And in some telescopes, this means your telescope is eventually going to hit something. And even if it doesn't hit something, it's going to pull cables, it's going to strip out gears, and so that can be a real problem. And I think one of the reasons I didn't get in more trouble for the filter I destroyed was because the people I was dealing with had burnt out engines on the 107-inch telescope because they forgot to turn off tracking. So it's,
We've yeah, even in our virtual star party, we've had people bonk into their telescope
mm,
domes or try to observe through
yeah,
the side wall of their dome. So yeah,
yeah,
cool. Okay, well I'm gonna
yeah.
let you get back to your conference, Pamela, but thank you very
That
much.
sounds good. Okay,
All right, we'll see
it's
you
been a
next week.
pleasure.
Are you back
Okay,
in you back
bye-bye.
in the country next week?
Yeah,
All right,
unless there's an airplane flaw, I will be ready to record on Monday.
that sounds great. All right, we'll talk to you later.
Okay, okay, bye-bye.
All right, I'm just gonna stop the recording. Okay, well I'm gonna wrap up the hang up just because I know you got to get back to it. So
Okay,
all right, cool, and then just don't forget to upload. And thanks everyone.
I
Sorry for the audio delay. Like I said, just don't look at it. Just put it behind a window and you'll be fine. All right, see you later. All right, there we go. Pamela, can you hear me?
I can hear you just fine.
Okay, so I just want to warn people in advance that there's a really big delay between the audio and the video. So when you hear Pamela talk, it then takes about another 5 seconds or so until you see Pamela talk. And this is happening because you're in Europe right now. You're hiding
I'm
in
in
some
Warsaw.
you're in Warsaw. You're hiding in some corner of a conference, right?
Yeah, I'm actually currently sitting behind the podium while we're on break. Heard of roll-off planetary, not roll-off observatory roofs, but never a roll-off planetarium dome. But they have a telescope and a planetarium projector inside of their planetarium, and so they'll just roll off the planetarium dome to look at the actual sky, and I think that's really kind of
Oh,
awesome.
like use a laser or something to point out objects in the sky.
Yeah, and they have tablet computers at the seats inside the planetarium so that people can control both the planetarium show and see what's coming off at the telescope, and it's
That's
just
really
a
cool.
really awesome. And there's been every
She was just gonna keep meowing at me if I didn't do that.
No, no problem. So I'm at this meeting is organized by the International Astronomical Union, Division 55, and we have 200 people from 40 different countries here. And we're all working to define ways to get astronomy out to broader audiences. And it's been kind of amazing. We've seen everything from planetarium shows to new planetarium technologies. There's actually a planetarium in rural Spain that the dome rolls off. So I've just sort of leaning against the wall in a mostly empty conference room. So this is where I am.
So what is the event that you're at right now?
I'm at the Communicating Astronomy to the Public meeting. I'm also sitting on the floor, which is a comfortable place to sit at the end of the day. I'm at the Communicating Astronomy to the Public meeting, which is hosted by the International Astronomical Union's Division 55.
Oh,
and
so I gotta let a cat out. Hold on one second.
Everything in between, from teacher training programs to citizen science programs to, well, everything.
So we don't have a lot of time today because you are really, taking stolen time in between the conference event. So let's just get rolling with the show, and we're not going to have time to stick around for questions today. And so again, if you're watching this and the delay is still happening, I highly recommend that we know that you just put another tab in front of your YouTube video, and then you can go from there. Okay, all right. So let's get ready to record. Are you ready to record?
Yeah.
Do you need to ask those people